So we can use Gibbs free energy calculations to provide us a very important piece of information that is very practical in chemical engineering and industrial production, the temperature at which a reaction becomes spontaneous. So let's first start off with a recap of what spontaneity actually means. Spontaneity is where a reaction favors products over reactants. And really from here on out, you really need to think of products versus reactants, because in theory, all reactions chemically are reversible. So as we shift conditions in the chemical reaction in a closed system, we can constantly be moving back and forth between more reactants or more products. And this is actually called Le Chatelier's principle, which we will get into at a later time. But for now, just simply understand is that a change in temperature will shift a reaction from one to the other. Will shift from favoring the product side, the right side of the arrow, to the left side of the arrow, or back again, depending on whether we're going up in temperature or down, and that change is something that may shift it one way or the other. So adding heat will shift an endothermic reaction to product side. In other words, it'll shift a reaction forward, so to speak. If we want to think of a chemical reaction as A plus B equals C or something like that, so the product side is the right side traditionally when we're discussing this stuff. So this is the product side. And then the left side of the arrow are the reactant side. And we just generally think of reactant left of the arrow, product to the right. So if we're endothermic and we add heat, we're going to push that reaction to the right. However, if we add heat to a system in a reaction that we've already run, or we're in the middle of running, it really doesn't matter, we will disrupt the equilibrium. Let's say we were at a stopping point in the reaction, it's had time to do its thing, we settled to a certain temperature, and we add some heat. Well, if it's an exothermic reaction, if it's a negative delta H, it's actually going to push the reaction backwards. It will undo some of that reaction. And the more extreme the heat shift, the more it's going to run back. If we remove heat from a reaction that's kind of come to equilibrium, it's come to a stopping point more or less, if it's an exothermic reaction, well, it's going to shift that exothermic to the right. It'll push towards more products if that is possible. And if it's an endothermic reaction and we remove heat from it, well, that's going to shift it to the left. So that's a fairly generalized set of statements that we can make. So if we have a situation where we are wanting to know, well, is a temperature going to make that reaction spontaneous or not? Is it going to shift or is it going to shift the reaction to the left or the right? We can use Gibbs by setting Gibbs essentially to 0 and solving for an unknown temperature. So let's take a look at how we do that. It's actually pretty simple.